how to create and interpret quantitative data. In short, your histogram will be your statistical representation or your statistical diagram. So here we go. So the first question is asking us to calculate statistical averages and variability. So averages are basically the mean, the mode, the median, and that is different based on the shape of your distribution, where it's located. And for variability, another word for this is basically your spread of your data. If it's the wide spread, a large spread, or if it's the innermost spread, which is your interquartile range, or if it's the spread between the minimum and the maximum, which is your range of data. Alright, so the data given below are some raw data, and they are 10, 39, 71, 42, 39, 76, 38, and 25. The first thing we do is to arrange our data. We always arrange data when you're trying to find any average. So the median is our main goal for this question. So you can arrange your data from smallest to largest, or from largest to smallest. So I'm going to go from smallest to largest. I don't see my red pen, but I'm going to write this color. So we're going to have 10. We have 25, 38, 39, 39 twice. And a quick way to do this is basically to cancel out the numbers as you go along, so you don't get yourself mixed up or you don't miss any numbers, alright? So I just arrange my data from smallest to largest. Now I'm going to go ahead and find the median. And the median is the middle of your data when your data is arranged. So I'm going to be canceling from either side until I get to my middle. So cancel 10, cancel 76, 25, 71, 38, 42. As you can see in the middle, we now have two numbers. So we need to find the middle of this two number. And both of them is 39. So what you do is to add both numbers and divide by 2. But since the number is 39, I know that the middle one is still 39. But you can go ahead and add them. So 9 and 9 is 18. You bring the 1, so 3 and 3, 6. 6 and 1 is 7. 78 divided by 2 is 39. And so my median is 39. Alright? From my median, from the data given, I can now find my minimum value. And my minimum value is your lowest value in your data set. And right here, we have 10 being the smallest number. So part B is asking us to find our lower quartile. So quartile basically comes from the root word quarter, that basically saying have a distribution between 0 and 100%. 50% of your data is in the middle, that's your Q2. From your 50%, if you find half of your upper half, that's where your Q1 is located, or your lower quartile, and that's 25% of the data. If you find half of your upper half, that's where your Q3 is located, and that's basically your upper quartile. So the quartile helps us to find the interquartile range, which is the innermost 50% of your data. So this is 25%, that's 25, that's 25, and that's 25. Alright, so from here, I need my lower quartile. I already know what my median is. In this case, my median is 39. My board is moving. Median is 39, so it's half of this data. So once my median is not a face value, I'm going to be taking half of the upper half and finding the middle. So I'm going to cancel from here, cancel 39, cancel 10. In the middle, I have two numbers, 25 and 38. Can you find that for us? What's 25 plus 38? $63, and 63 divided by 2 is 31.5. So 31.5 is our lower quartile. We now need to find our upper quartile, which is half of the upper half of our data. So we're going to cancel 39, cancel 76. In the middle, we have two numbers, 42 and 71. Let's add those two numbers. We have 113. When we add them, we divide that by 2. Will give us 56.5. So that's our upper quartile of our data. So to find your interquartile range, which is a shortened form for IQR, it's basically Q3 minus Q1. So your upper quartile minus your lower quartile. And your upper quartile is 56.5, and your lower quartile is 31.5. Now we're going to go ahead and we're going to do our subtraction. And your answer should give you 25. Alright, so your interquartile range is 25. If you look at the data I draw here, it's basically describing this region, the innermost 50%. So between Q1 and Q3. Now we're going to find our range. And the range is the spread of your data from the minimum to the maximum. You basically find the difference between those. So range is your maximum minus your minimum. And your maximum value is 76. And your minimum value is 10. So 76 minus 10 is 66. And there you go for your data. So we need to always remember how to find the averages and the spreads if you're given raw data or group data. But we'll get to the group data very soon. So this part we are asked to create and describe your quantitative distribution. It says make a dot plot of the data in your own words. Explain how you describe the shape and the spread of your distribution, and you must always state your context. So context helps us understand what the data is about, who is it about, and why it's important. So we always state context. So here we have miles run per day, and we have some raw data. So we're asked to create a dot plot. A dot plot is a statistical diagram that is drawn on a number line where you ensure you have your margins from your smallest to your largest number, and we have our title helping us understand what the data is about. So I'm going to go ahead and draw my number line. My smallest number here is 0, and my largest number is 6. So I'm going to count to 6. My number line will not be drawn to scale, but if your teacher is a person who needs that, you can go ahead and draw it to scale. But that's a rough sketch of my number line. So for your dot plot, the dots are used to represent the data value. And so, for example, 0 is here twice. So above 0, I'm going to have 2 dots. And this tells me what your raw data is or was. So right here, I have 1 appearing 4 times. Above 1, I'll put 4 dots. I have 2 appearing 1, 2, 3, 4, 5, 6 times. So 1, 2, 3, 4, 5, 6. Alright, 3 appearing 1, 2, 3, 4 times. 1, 2, 3, 4. And we have 4, 1, 2, 3 times. 1, 2, 3. We have 5, 1, 2 times. 1, 2, and 6 appearing once. So your dot plot representing miles run per day. And you are finished. Now they want us to describe the shape and the spread. So there are 2 ways to describe the shape of your distribution. You first examine what it looks like. A quick way to do this is to draw a bell curve over your data and see if your curve is symmetrical or if it's skewed. So right here we see our curve, our bell curve looks skewed in my eyes. It looks skewed to me, and its direction depends on the tail of your bell curve. And the tail is where the data is kind of ending. And in this case, ending from this side, so we say it's skewed to your right. So the shape of the distribution is skewed to the right. Alright? So it's skewed to the right, and the spread. So once you talk about spread, if your data is skewed, you can describe the range or the interquartile range. I normally go for the simplest one because they mean the same thing. And so I'm going to talk about the range in this. So the spread has a range of, in this case, we look to see the largest number. So it's 6 minus 0 to give us 6. So the range has a value of 6 miles, or you want to say the data has a range of 6. Up to you how you describe it. So that's basically how you go ahead and describe your distribution, and that's where your points will come in. So the shape and the spread are already explained. Let's move on to the next one. So this part says describe the shape, the center, the unusual feature, and the spread of each distribution. As I was explaining to you earlier, that you have two ways of doing this. Your data is described using the method known as the SOX method. The first S is the shape, the second O, the O here is the outlier or any unusual feature. The C represents the center, and the S here represents the spread. So again, I'm going to draw a bell curve over my distribution to see what the shapes look like. And in this case, the shape here looks roughly skewed. And since it's skewed, I must tell the direction of my skewedness. So it's skewed to the right as it's trending downwards to the right, all right? So we're going to say skewed right. For the outlier, I look to see if there's any gap, any cluster, or any other unusual feature. In this case, there are none because all the intervals are accounted for. So we're going to say no unusual feature. For the center, since as my data is skewed, I'm going to tell my median. And since I don't have raw data, I'm going to roughly estimate the median class. And so, in previous lessons, we've explained that based on how your data is skewed, you know which of them is greater. So if your data is skewed to your right, I'm going to put SR right here, skewed to your right, or if it's skewed to your left, here the mode will be the highest column, the median will come after, and the mean is somewhere down here, roughly an estimate like that. So since mine is skewed right, I know that my mode is going to be in the highest class, so my median could be in the same class or the class next to it. So I'm going to take the class next to it. So I'm going to say my median class, let's erase that, my median class is 10 to 14. 10 to 14 minutes. Let's erase this part. 10 to 14 minutes. For my spread, I'm going to describe my range. And my largest value here is 29. That's my maximum value. My minimum value here is 0. So my range is 29 minutes. So it has a spread of 29 minutes where the median or the center is between 10 and 14 based on my distribution here, and my data is skewed. It's skewed to the right. Let's go describe the second one that has to do with the heights of plants. So again, I always draw my bell curve over it to see what it roughly like. In this case, I see that it is symmetrical because you can flip the right hand side on the left hand side perfectly or almost perfectly. So again, I'm going to list my SOX. I'm going to be describing this. So S, it is symmetrical in shape. And for symmetrical distribution, you will know that the mean, the mode, the median, they're all in the same place or the same interval. So right here, any outlier, there is none. For the center, I'm going to say the center has a mean In this case, 18 would be our center, so the mean of 18 for the spread. I'm going to talk about my standard deviation. So for my standard deviation, if you were not taught how to calculate this, you basically describe it as a small spread or a large spread. How do you know if it's small or large? When you draw your bell curve over it, I'm going to give you a sample of that. So let's say my bell curve looks like this, and my center is right here. Depending on how wide my distribution is, I would say it has a large spread. But for it to have a small spread, you'll see that the curve is kind of squished together. For example, this one, you see the spread is small. So the more squished together I don't know how to describe this. More squished together your bell curve is the smaller the standard deviation is. So like this one will have a small standard deviation. And this one, depending on what the numbers are as well. Because here, between 18 and 21, that's just 3. So even though the curve looks big because the diagram is expanded, this still has a small standard deviation. Because this number here will be like a 3 spread there and a 3 spread here. Sometimes if your number is like half or more of the center, in this case it's 18. So if the numbers were like 9 on either side, we will say it's roughly large. But in this case, there are small numbers between 18 and 21. So that's roughly a 3 spread. So we're going to say it has a small standard deviation. So there are different ways you can explain your spread based on your understanding. So it can be a large spread if the bell curve, as I said, is almost flattened to the x-axis, or if it's squished, it's going to be a small spread. Alright guys, thank you very much for watching. I hope you enjoyed this video. Remember to like, comment, subscribe, tell a friend to tell a friend, then come and learn something, because